President Biden has presented the first picture to be shown openly from the James Webb Space Telescope. Underneath the immense seas lie secrets that outperform creative mind, leftovers of lost history, and spooky indications of something going on under the surface. Once flourishing, they are ready to be revealed. Yet, in the midst of the charm of disclosure, there's a sprinkle of disquiet. Consider the possibility that these mysteries were never intended to be tracked down. Plunge with us as we dive deep into 15 submerged disclosures that have left even the most valiant pilgrims shudder. Prepare to be both captivated and frightened. The launch of the James Webb Space Telescope in 2021 was an unbelievable occasion. It took off very high atop a strong European Ariane 5 rocket in the midst of the rich woodlands of South America, adding a bit of nature's glory to the event. Countless researchers from all over the planet had poured their aggregate expertise and effort into this task for many years, culminating in this groundbreaking accomplishment. However, such stupendous undertakings come with colossal risks, and the possibility of disappointment loomed as a potential threat. Marvelously, everything unfolded with close to wonderful accuracy. The telescope set out on an excursion traversing almost 1,000,000 miles, persevering through 30 days of movement through the void of space. Its definitive objective was the confounding Lagrange point 2, a spot in space where gravity keeps a fragile balance opposite the Sun according to Earth's orbit. This spot had previously become home to other space telescopes like the Hubble Space Telescope and the Spitzer Space Observatory, making it an ideal vantage point for the James Webb Telescope to begin its infinite journey. As the James Webb Space Telescope embarked on its excursion, NASA divulged its aggressive plan, framing 4 essential domains of investigation. First and foremost, the telescope aimed to witness the universe's debut eruption of light, a crucial crossroads in astronomical history. It sought to test the old heavenly past, uncovering the mysterious gathering of worlds during the universe's initial stages. Beyond this infinite archaic exploration, the JWST was also ready to reveal divine exhibitions of extraordinary importance. It longed to look into the cradles of stellar birth, revealing insights into the beginnings of stars and the development of protoplanetary systems. In addition, its journey extended to the scene of planets, diving into the amazing story of planetary existence, including the tricky origins of life itself. These scientific frontiers had long escaped far-reaching investigation due to the inherent challenges of exploring the universe. Before embarking on its divine observations, the JWST underwent a meticulous series of scientific tests and adjustment techniques, including the deployment of an astounding protective shield designed to protect its fragile instruments from the constant assault of the sun's heat and blinding brilliance. Given the telescope's interminable journey through the cosmic void, this shield was critical. The Sun Shield, a tremendous structure made out of 5 rigorously layered films, had been cautiously folded like a complicated accordion. The unfurling process demanded an exact movement of steps, guaranteeing proper tension and arrangement of each and every layer. The stakes were huge, as any misalignment or damage to this vast guardian could imperil the telescope's ability to observe the far-off, confounding realms of the universe. With help, it cruised through the early tests, preparing to face the next challenge. The impending task was to open up the telescope, another highly sensitive process. Despite being definitively positioned, it required careful preparation to fulfill its cosmic duties. At the core of the JWST lay its primary mirror, a complicated mosaic of 18 hexagonal pieces that demanded perfect synchronization to create sharp celestial images. The preparation of the JWST was a dance of intricacy and delicacy, involving not only the unfurling of its gigantic sun shield but also the seamless extension of its support structure and the gradual unveiling of its main mirror. However, the mirror's exposure marked just the beginning of the precision work. Each component needed to align immaculately to enable the JWST to carry out its scientific mission. Another complex calibration involved awakening the Webb's scientific instruments one by one, as if stirring dormant sensors. These instruments included the near-infrared camera NIR-CAM, the near-infrared spectrograph NIR-SPEC, and the mid-infrared instrument MIRI, each with unique capabilities to probe the universe and add layers of discovery to the mission. Equally significant was the telescope's alignment process, known as phasing, which involved refining its focus and locking onto celestial targets with pinpoint accuracy. These trials acted as a safeguard, ensuring that the Webb telescope was prepared to embark on its odyssey and uncover yet unknown secrets of the universe. As these complex operations unfolded, a sense of anticipation swept through the scientific community. Everyone held their breath, hoping for success, knowing full well that in the world of science, things don't always go as planned. To everyone's wonder, the JWST passed each test flawlessly, an achievement that is nothing short of astounding. This monumental project united more than 300 universities, associations and organizations from 29 states and 14 different countries. Then, in July 2022, after enduring and overcoming each challenge, NASA gave the green light for the James Webb Space Telescope to commence its incredible scientific journey. NASA proudly announced that all 17 of the observatory's scientific instrument modes had passed rigorous testing and were ready to go. Like other telescopes, the JWST's primary role is to gather and focus light, revealing distant celestial wonders. But what makes the JWST extraordinary is the specific portion of the electromagnetic spectrum it observes. While human eyes are limited to seeing visible light, the JWST sees far beyond, into the hidden realm of infrared phenomena. It's a transformative shift in perspective, opening new horizons as we continue our quest to understand the universe. The James Webb Space Telescope is like an invaluable heat seeker, similar to an advanced night vision camera, capable of gazing into the universe's depths on a grand scale. Its massive size allows it to gather more light than any other telescope, enabling it to peer at much smaller, more distant cosmic phenomena. But here's the most exciting part. It's stationed in space, free from the atmospheric disturbances that often blur our view. That's why they call it the universe's keen eye. But how does this marvel work? At its core is an enormous 21-ton reflector. This massive reflector captures and bounces light back to the telescope's complex instruments. Speaking of instruments, the JWST is equipped with a quartet, each with its own celestial prowess. First, we have the near-infrared camera, the JWST's primary eye. This high-tech lens captures stunning images of distant galaxies, nebulae, and other celestial wonders. Next is the near-infrared spectrograph, which acts like a cosmic prism, splitting light into its rainbow of colors and revealing secrets about the objects it observes. Then there's the mid-infrared instrument, specially designed to collect infrared light. It delves into the mysteries of the early universe, investigates exoplanets, and even takes a closer look at our own solar system. Lastly, there's the fine guidance sensor and near-infrared imager and slitless spectrograph, high-precision tools that ensure the JWST stays on course and is highly sensitive to near-infrared light. With this combination of tools, the JWST leaves no cosmic stone unturned. The true magic lies in its ability to observe the expanding universe. As the universe stretches and grows, light from distant corners of space becomes redshifted, meaning its wavelengths are stretched, making it appear redder. By observing the universe in this redshifted light, we can literally look back in time, seeing the universe as it was in its early days. Imagine witnessing the birth of stars and galaxies and learning about the ancient conditions of our universe. The James Webb Space Telescope has the power to amaze, to peer deep into the cosmos, allowing us to look back in time. The farther an object is from us, the longer its light takes to reach our telescopes. Therefore, when the JWST focuses its lenses on a distant galaxy, we are seeing the universe as it was billions of years ago. President Biden has presented the first picture to be shown openly from the James Webb Space Telescope. Beneath the immense seas lie secrets that outperform creative minds, remnants of lost history, spooky indications of something once flourishing ready to be revealed. Yet, in the midst of the charm of discovery, there is a sprinkle of disquiet. Consider the possibility that these mysteries were never meant to be found. Plunge with us as we dive deep into 15 submerged discoveries that have left even the most valiant explorers shuddering. Prepare to be both captivated and frightened. The launch of the James Webb Space Telescope in 2021 was an incredible event. It soared high atop a powerful European Ariane 5 rocket amidst the rich woodlands of South America, adding a touch of nature's glory to the occasion. Countless researchers from across the globe poured their collective expertise and effort into this project for many years, culminating in this groundbreaking achievement. However, such grand undertakings come with colossal risks, and the possibility of failure posed a significant threat. Marvelously, everything unfolded with near-perfect precision. The telescope embarked on a journey traversing almost 1,000,000 miles, enduring 30 days of travel through the void of space. Its ultimate destination was the mysterious Lagrange point 2, a place in space where gravity maintains a delicate balance opposite the Sun, according to Earth's orbit. This spot had previously housed other space telescopes, like the Hubble Space Telescope and the Spitzer Space Observatory, making it an ideal vantage point for the James Webb Telescope to begin its infinite journey. As the James Webb Space Telescope embarked on its voyage, NASA revealed its ambitious plan, outlining 4 essential domains of investigation. First and foremost, the telescope aimed to witness the universe's initial burst of light, a crucial crossroads in astronomical history. It sought to explore the ancient celestial past, uncovering the mysterious assembly of worlds during the universe's early stages. Beyond this archaic exploration, the JWST was also poised to reveal cosmic exhibitions of extraordinary significance. It longed to peer into the cradles of stellar birth, unveiling insights into the origins of stars and the development of protoplanetary systems. In addition, its journey extended to the realm of planets, delving into the astonishing story of planetary existence, including the elusive origins of life itself. These scientific frontiers had long eluded comprehensive study due to the inherent challenges of exploring the cosmos. Before embarking on its cosmic observations, the JWST underwent a meticulous series of scientific tests and calibration procedures, including the deployment of an astounding protective shield designed to safeguard its delicate instruments from the constant onslaught of the sun's heat and blinding brilliance. Given the telescope's endless journey through the cosmic void, this shield was crucial. The Sun Shield, a massive construct made of 5 meticulously layered films, had been carefully folded like an intricate accordion. The unfolding process required precise steps, ensuring proper tension and alignment of each layer. The stakes were enormous, as any misalignment or damage to this vast guardian could jeopardize the telescope's ability to observe the distant, confounding realms of the universe. With care, it sailed through the initial tests, preparing for the next challenge. The subsequent task was to deploy the telescope, another highly delicate procedure. Despite being in its designated position, it required meticulous preparation to fulfill its cosmic duties. At the heart of the JWST lay its primary mirror, a complex mosaic of 18 hexagonal pieces that demanded perfect synchronization to produce sharp cosmic images. The preparation of the JWST was a ballet of intricacy and finesse, involving not just the deployment of its gigantic sunshield but also the graceful extension of its support structure and the gradual revelation of its primary mirror. However, the mirror's unveiling marked only the beginning of the process. Every component needed to align flawlessly to enable the JWST to fulfill its scientific mission. Another complex calibration test involved activating the Webb's scientific instruments individually, as if awakening dormant sensors. These instruments included the near-infrared camera, the near-infrared spectrograph, and the mid-infrared instrument, each with its unique capability to observe the universe, adding layers of fascination to the mission. Equally important was the telescope's alignment of its invaluable orientation, a process known as phasing. This involved engaging the telescope in fine-tuning markers and refining its aim, ensuring that its instruments were locked onto celestial targets with pinpoint accuracy. These trials served as gatekeepers, ensuring that the Webb telescope was ready to embark on its odyssey and unveil yet unknown secrets of our universe. As these intricate systems unfolded, a sense of anticipation swept through the academic community. Everyone held their breath, awaiting success, knowing full well that in the realm of science, things often don't go as planned. To everyone's astonishment, the JWST sailed through each test flawlessly, a feat nothing short of remarkable. This monumental project united over 300 universities, associations and organizations from 29 states and 14 different countries. Then, in July 2022, after enduring and overcoming each challenge, NASA gave the go-ahead for the James Webb Space Telescope to embark on its scientific journey. NASA proudly announced that all 17 of the observatory's scientific instrument modes had undergone rigorous testing and were now considered ready to operate. Like other telescopes, the JWST's primary role is to gather and focus light, uncovering distant celestial wonders. However, what sets the JWST apart is the specific slice of the electromagnetic spectrum it observes. While our human eyes are limited to visible light, the JWST sees beyond, into a hidden realm of cosmic peculiarities. This is a paradigm shift, opening new horizons as we continue to search for understanding of the universe. The James Webb Space Telescope is akin to an invaluable heat seeker, like a cutting-edge night vision camera capable of peering into the depths of the universe on a grand scale. Its enormous size allows it to collect more light than any other telescope, letting it observe much smaller and more distant cosmic wonders. Yet, here's the best part. It is positioned in space, free from those troublesome atmospheric obstructions that often obscure our view. That's why they call it the universe's perfect focus. But how does this marvel actually work? At its core, it boasts a massive 21-ton reflector. This enormous reflector captures and bounces light back to the telescope's intricate instruments. The JWST is equipped with 4 main instruments, each with its own unique cosmic prowess. First up is the near-infrared camera, the JWST's primary eye. This high-tech lens captures breathtaking images of distant galaxies, nebulae, and other celestial wonders. Next is the near-infrared spectrograph, which acts like a cosmic prism, splitting light into its rainbow of colors, revealing secrets about the objects it observes. Then there's the mid-infrared instrument, uniquely tailored to gather infrared light. It delves into the mysteries of the early universe, studies exoplanets, and even takes a closer look at our own solar system. Lastly, there is the fine guidance sensor, near-infrared imager, and slitless spectrograph. These highly accurate devices ensure the JWST remains precisely focused and sensitive to nearby infrared light. Together, this suite of instruments leaves no cosmic stone unturned. The real magic lies in understanding the expanding universe. As the universe expands and evolves, light from distant parts of space becomes redshifted, its wavelengths stretched out, making it appear redder than in its original form. By observing the universe in this redshifted light, we can literally look back in time, witnessing the universe as it was in its early days. Imagine seeing the birth of stars and galaxies, learning about the ancient conditions of our universe. The James Webb Space Telescope has the power to astonish, allowing us to peer deep into the universe and, in a sense, back in time. The farther an object is from us, the longer its light takes to reach our telescopes. Thus, when the JWST focuses its lenses on a distant galaxy, it isn't just capturing an image of the present. Rather, it's like a cosmic time machine revealing what that galaxy looked like billions of years ago when its light began its interstellar journey.